Hi everyone, Vagif here. Today I'm going to present my EE102 digital design project. This is a gesture-controlled RC car. It's controlled by a glove, and now we will get into some brief overview of the project in terms of its design, and then we're going to show a demo, and that will conclude the video. So to implement the gesture controls, I'm using an accelerometer and gyroscope sensor. This is called GY521. It's based on the MPU 6050 chip on the center. It has multiple sensors in it, but the ones I'm using are the accelerometer and the gyroscope data. So I'm taking data from this sensor via two lines. This is based on the process is based on the I2C interface. It's a two-line interface with serial clock and serial data lines. Then in the FPGA board, the basic 3 FPGA board, I'm processing this data, and then in order to transmit it to the other side, to the car, I'm using a UART interface. UART interface is basically a serial line with a specified baud rate, bit rate. So here I'm outputting a single line of serial data in a specific rate to the HC12 transceiver. This transceiver is very capable and up to 1.5 kilometers distance, and it transmits the accelerometer data with its antenna and to its counterpart on the car. Here I've put it in here. This is the same sensor, same module, and it receives the data. Then the data is processed on my Arduino Nano board. I'm using the same interface with the same baud rate there. I will show you the process and all of the things in the computer after a while now. Then I'm using in order to drive the motors, the DC motors, I'm using a L298 motor driver. It uses 4 pins in order to get the data, and after processing the data in the Arduino board, I'm sending analog write inputs to the motor driver, and that way it drives the DC motors. Here is the Arduino code that I wrote for the receiver part. Here we're using the software serial package. We have the data is coming to the one of the input pins, digital input pins of the Arduino board, and here we are specifying 9600 baud rate. This is what the basis 3 board is also using, so they are in sync, and it will display the data. In order to show what's coming here to the serial monitor, we are printing the serial monitor in the serial monitor, and here is the data. This is automatically converted to decimal form. The 8-bit data is converted to the decimal form. So when I change it, change the orientation of the sensor, we can see that it changes. And I am processing this, I'm writing a loop to process this data, and according to that, we're outputting the motor driver input pins. So the motor is turning, and to do that we are also using the analog write inputs. With analog write we can specify the speed of the motors, DC motors, and 255 is the maximum it can get. And so everything is covered right now, and we're moving on to the demo part.